Here we are, floating on a tiny rock through an infinite cosmos, breathing air that shouldn't exist, made of atoms that defy the very laws that created them. By all accounts, according to our best physics, our universe should have destroyed itself in the first fraction of a second after it began. Yet somehow, impossibly, beautifully, it didn't. Welcome back to another gentle journey through the mysteries that surround us. I'm here to explore with you one of the most profound puzzles in all of science, a question so fundamental that it challenges everything we think we know about existence itself. Tonight we're going to wander through the looking glass of modern physics and discover why, according to our most sophisticated theories, you shouldn't be here to listen to these words. Before we drift into this cosmic mystery together, I'd love to know where you're joining me from tonight. Are you curled up in bed somewhere in Tokyo as the city lights twinkle outside your window? Perhaps you're taking a late evening walk through the quiet streets of Stockholm. Or maybe you're settling into your favourite chair in Melbourne while the afternoon sun filters through your curtains. Wherever you are, whatever time it is in your corner of the world, take a moment to appreciate the simple miracle that you exist at all. If you find these explorations meaningful, a gentle tap of the like button helps this little corner of curiosity reach others who might need these quiet moments of wonder. And if you haven't already, consider subscribing for more journeys into the beautiful mysteries that surround us every day. Now, settle in comfortably. Let your breathing slow and your mind open to possibilities that stretch far beyond our everyday experience. What I'm about to share with you isn't science fiction or philosophical speculation. These are the conclusions that emerge when we follow the mathematics and observations of modern physics to their logical endpoints. And those endpoints reveal something extraordinary about the nature of reality itself. The universe, it turns out, is balanced on the edge of a knife, so sharp, so impossibly precise that the slightest deviation in any direction would have meant that nothing, absolutely nothing, could exist. No stars, no planets, no chemistry, no life, no consciousness to contemplate these mysteries. Just empty space, forever dark, forever silent. As you listen tonight, I invite you to let these ideas wash over you like gentle waves. Don't worry about remembering every detail or grasping every concept immediately. Sometimes the most profound truths reveal themselves not through intense focus, but through patient, open attention to what emerges in the quiet spaces between thoughts. Let's begin our journey at the very beginning, in those first impossible moments when everything we know came into existence. Imagine, if you will, the universe as it was in the first fraction of a second after the Big Bang. Not the serene cosmos we observe today, with its stately galaxies and patient stars, but something far more chaotic and violent, a seething cauldron of pure energy, so hot and dense that matter and antimatter particles were constantly popping into existence and immediately destroying each other in brilliant flashes of annihilation. This wasn't some distant cosmic drama playing out in empty space. This was the fundamental nature of reality itself in those early moments. Every point in space was alive with this dance of creation and destruction, as particles and their antimatter twins materialized from pure energy and then obliterated each other, returning to the light from which they came. Now here's where our story takes a turn that should have ended everything before it even began. According to the most basic principles of physics, matter and antimatter should always be created in exactly equal amounts. They're like cosmic twins, identical in every way except for their opposite charges. When they meet, they don't simply disappear. They transform completely into pure energy. Following Einstein's famous equation, with perfect mathematical precision. In these first moments of the universe, this process was happening everywhere, all at once, on an unimaginable scale. Trillions upon trillions of particles were being born and dying in the cosmic furnace, each annihilation releasing a burst of energy that contributed to the incredible heat and light of the early universe. But here's the mystery that keeps physicists awake at night. If matter and antimatter were created in exactly equal amounts, as our theories predict they should have been, then every single particle should have found its antimatter partner. Every proton should have encountered an antiproton, every electron a positron, should have met, and in their mutual annihilation, they should have left behind nothing but photons of light racing through empty space. The universe should have become nothing more than a vast ocean of radiation, cooling and expanding forever, but empty of any structure, any complexity, any possibility for the rich tapestry of existence we see today. No atoms could have formed, no stars could have ignited, no planets could have coalesced from cosmic dust. The universe would have been beautiful in its own way, perhaps, but utterly lifeless and eternally simple. Yet obviously, catastrophically for our theories, but wonderfully for us, this complete annihilation didn't happen. Instead, after all the matter and antimatter had finished their cosmic dance of destruction, something remained. A tiny surplus of matter, perhaps just one extra particle for every billion pairs that annihilated, survived the great cleansing. This minuscule imbalance, this cosmic rounding error, is literally everything. Every atom in your body, every star in the night sky, every grain of sand on every beach, every breath of air you've ever taken, all of it exists only because of this impossibly small asymmetry in the early universe. Scientists call this the baryon asymmetry problem, and it represents one of the deepest mysteries in all of physics. The name might sound technical, but the question it poses is beautifully simple. Why is there something rather than nothing? Why did even a tiny fraction of matter survive when, by all rights, everything should have been destroyed? Take a moment to let this sink in. As you sit there listening, consider that every particle that makes up your physical form is a survivor of the greatest catastrophe that never quite happened. You are made of matter that somehow escaped complete annihilation in the first moments of cosmic history. In a very real sense, you are composed of the universe's most precious survivors, the remnants of a cosmic lottery where the odds of winning were less than 1 in a billion. Recent discoveries have begun to shed light on this profound mystery. Scientists have found that nature does indeed distinguish between matter and antimatter in subtle but crucial ways. These differences, called CP violations, are incredibly small, but they appear to be exactly what was needed to tip the cosmic scales in favour of matter's survival. The discovery of these asymmetries represents some of the most important work being done in physics today. When researchers observed that particles containing charm quarks behave differently from their antimatter counterparts, differing by only about 0.1%, they weren't just making another technical measurement. They were uncovering clues to the deepest question of existence itself. But even with these discoveries, the full picture remains beautifully mysterious. The asymmetries we've found so far aren't quite enough to explain the amount of matter we see in the universe today. There must be other mechanisms at work, other subtle ways that nature broke the perfect symmetry between matter and antimatter in those crucial early moments. As we continue our exploration of why the universe shouldn't exist, we encounter another puzzle that strikes at the very heart of what we mean by nothingness. For most of human history, we've thought of empty space as exactly that, empty, a void where nothing happens, where nothing exists, where silence and stillness reign supreme. But quantum mechanics, that strange and beautiful theory that describes the behaviour of the very small, reveals that this intuitive picture is profoundly wrong. What we call empty space, the vacuum of the universe, turns out to be one of the most active, energetic places imaginable. At the quantum level, empty space seethes with activity. Virtual particles constantly pop into existence from pure nothingness, live their brief lives, and then vanish back into the void from which they came. It's as if the vacuum itself is restless, unable to remain perfectly still even when cooled to the absolute zero of temperature. This isn't just theoretical speculation. We can measure the effects of these quantum fluctuations in the laboratory. When physicists place two metal plates extremely close together in a vacuum, these invisible fluctuations create a measurable force that pushes the plates together. This Casimir effect, named after the Dutch physicist who predicted it, is direct evidence that empty space isn't empty at all, but filled with a subtle kind of energy that we're only beginning to understand. Now, here's where our story takes another turn toward the impossible. When physicists try to calculate how much energy these quantum fluctuations should contribute to the expansion of the universe, they run into what has been called the worst prediction in the history of physics. The mathematics of quantum field theory suggest that the vacuum should contain an enormous amount of energy, enough to cause the universe to expand so rapidly that atoms themselves would be torn apart almost instantly. We're not talking about a small miscalculation here. The theoretical prediction is larger than what we observe by a factor of 10 followed by 120 zeros. That's a number so large that if you try to write it out, you'd need more paper than there are atoms in the observable universe. This discrepancy is so vast, so incomprehensible, that it challenges our most fundamental understanding of how the universe works. It's as if we calculated that a marble should weigh as much as a mountain, or that a whisper should be as loud as a thunderstorm. The universe, according to our best theories, should have either collapsed immediately or expanded so violently that no structure could ever form. And yet, here we are. The universe expands at exactly the right rate to allow galaxies to form, stars to ignite, planets to coalesce, and complexity to emerge over billions of years. The vacuum energy, whatever its true nature, is balanced with exquisite precision against other forces in a cosmic dance that has persevered for nearly 14 billion years. This balance is so delicate, so finely tuned, that it seems to require a conspiracy of cosmic proportions. If the vacuum energy were even slightly different, if the balance were disturbed by the tiniest amount, the universe as we know it could not exist. Some physicists have proposed that we might be living in what's called a false vacuum, a state that appears stable but is actually balanced precariously on the edge of a cosmic cliff. Like a ball balanced on top of a hill, our universe might be stable for now, but a small disturbance could send it tumbling into a lower energy state, fundamentally changing the laws of physics themselves. If such a transition were to occur, it would propagate through space at the speed of light, creating an expanding bubble of new physics that would transform everything it touched. The constants that govern how particles interact, the forces that hold atoms together, the very nature of matter itself, could all change in an instant. Fortunately, if our universe is indeed in such a metastable state, the timescales involved are much longer than the current age of the cosmos. We're talking about lifetimes measured not in years or even billions of years, but in periods so vast that they dwarf the entire history of everything we've ever known. but the possibility remains, adding yet another layer to the mystery of why the universe exists at all. Not only shouldn't it have formed in the first place, but even if it did, it might not be stable in the long term. We exist, it seems, in a brief moment of cosmic tranquility between the chaos of creation and the possibility of fundamental change. As you contemplate these ideas, notice how they might shift your perspective on the ordinary moments of your day. The simple act of breathing, the warmth of sunlight on your skin, the weight of your body resting wherever you are right now. All of these everyday experiences are balanced on foundations more delicate and mysterious than we ever imagined. Our journey into impossibility continues as we examine the fundamental constants that govern reality itself. These numbers, discovered through centuries of careful measurement and experimentation, determine everything from how atoms hold together, to how stars burn, to how galaxies form across the cosmos. What makes these constants so remarkable isn't just their values, but their precision. They appear to be calibrated with an accuracy that defies comprehension, fine-tuned to allow for the existence of complexity, chemistry, and ultimately consciousness itself. Consider the strong nuclear force, the power that binds protons and neutrons together in the heart of every atom. This force had to be calibrated with extraordinary precision for our universe to exist. If it were just 2% weaker, atomic nuclei with more than one proton couldn't form. The universe would contain only hydrogen, the simplest element, and nothing more complex would be possible. No carbon for organic chemistry, no oxygen for water, no silicon for rocky planets, no iron for blood. But if the strong force were just 2% stronger, the opposite catastrophe would unfold. All the hydrogen in the universe would have been converted to helium and heavier elements in the first moments after the Big Bang. There would be no hydrogen left to fuel the long, slow burning of stars, no hydrogen to combine with oxygen to make water. Stars would burn out quickly, and the delicate chemistry of life would never have a chance to emerge. 2%. In a universe governed by forces that span dozens of orders of magnitude, the strong nuclear force had to land within a window of just 2% to make our existence possible. The electromagnetic force presents another example of cosmic precision that borders on the miraculous. This force, which governs how charged particles interact, had to be balanced against gravity with stunning accuracy. The ratio between these forces is approximately 1 followed by 36 zeros. If this ratio were significantly different, the delicate architecture of atoms would collapse, and chemistry, as we know it, couldn't exist. Stars, those cosmic furnaces that forge the elements essential for life, require their own precise balance. They exist in a constant struggle between the inward pull of gravity and the outward pressure generated by nuclear fusion in their cores. If gravity were slightly stronger, stars would collapse before they could create the heavier elements necessary for rocky planets and biological chemistry. If gravity was slightly weaker, stars might never ignite their nuclear fires at all, leaving the universe dark and cold. But perhaps the most stunning example of cosmic fine-tuning involves the overall geometry and expansion of the universe itself. Our cosmos appears to be balanced on a knife's edge between eternal expansion and eventual collapse. The density of matter and energy in the universe is remarkably close to what cosmologists call the critical density, the precise value that separates these two fates. The precision required for this balance is almost impossible to comprehend. In the early universe, the density had to match the critical value to within 1 part in 10 followed by 62 zeros. To put this in perspective, imagine trying to throw a dart at a target so small that if the target were the size of a proton, the dart would have to be thrown with accuracy measured across the entire observable universe. This is like balancing a pencil on its point, not just for a moment, but for nearly 14 billion years. Any tiny deviation, any microscopic disturbance would have sent the universe either collapsing back on itself almost immediately or expanding so rapidly that no structure could ever form. The flatness of space itself required similar precision. The universe appears to be geometrically flat on the largest scales, meaning that parallel lines remain parallel and triangles add up to exactly 180 degrees, just as they do on a flat sheet of paper. But maintaining this flatness over cosmic time requires initial conditions so precisely calibrated that they strain the bounds of probability. These examples represent just a small sampling of the apparent fine-tuning that permeates the cosmos. The masses of fundamental particles, the strengths of the various forces, the rate of cosmic expansion, the formation of the first elements, all of these had to fall within incredibly narrow ranges for our universe to become the rich, complex, beautiful place we observe today. Some scientists have calculated that if you randomly selected values for the fundamental constants, the probability of getting a universe capable of supporting complexity would be vanishingly small. We're talking about odds so remote that they make winning the lottery seem like a certainty. And yet here we are, living in what appears to be an impossibly well-tuned cosmic machine, where every gear meshes perfectly with every other gear, where every constant harmonizes with every other constant to create a symphony of existence that has been playing for nearly 14 billion years. As we'll explore in our continuing journey, this apparent fine-tuning raises profound questions about the nature of reality itself. Are we living in one universe among countless others, where only the rare few happen to have the right conditions for complexity? Is there some deeper principle that explains why the constants have the values they do? Or are we missing something fundamental about the nature of existence itself? As we drift deeper into the heart of this cosmic mystery, we encounter perhaps the strangest chapter in our story of impossible existence. It's a tale that begins in the sterile laboratories of the early 20th century and leads us to question the very nature of reality itself. Here, in the realm of quantum mechanics, we discover that the universe doesn't just defy our expectations about matter and energy, but challenges our most basic assumptions about the relationship between observer and observed. Picture, if you will, a single photon of light, a tiny packet of energy racing through space. In our everyday experience, we expect such a particle to have a definite path, a clear trajectory from point A to point B. But quantum mechanics tells us something far more mysterious. That photon doesn't follow a single path at all. Instead, it exists in what physicists call a superposition, simultaneously exploring every possible route until the moment we choose to observe it. This isn't merely a limitation of our measuring instruments or a gap in our knowledge. According to our best understanding of quantum mechanics, particles genuinely exist in multiple states simultaneously until they're observed. It's as if reality itself remains fluid, undecided, until consciousness turns its attention toward it. The implications of this discovery ripple outward, like waves on a cosmic pond. If the fundamental building blocks of reality don't have definite properties until they're observed, what does this say about the nature of existence itself? Are we passive witnesses to a predetermined universe, or do we play a more active role in shaping the reality we experience? Consider the famous double-slit experiment, a deceptively simple setup that has puzzled physicists for decades. When we fire electrons one at a time through two parallel slits toward a detector screen, something remarkable happens. If we don't observe which slit each electron passes through, they create an interference pattern on the screen, as if each electron somehow went through both slits simultaneously and interfered with itself. But the moment we place a detector at one of the slits to observe which path the electron takes, the interference pattern disappears. The electrons begin behaving like ordinary particles, each one definitively passing through one slit or the other. The very act of observation seems to collapse the quantum superposition and force reality to make a choice. This isn't a matter of the detection equipment disturbing the electrons. Physicists have devised experiments so subtle, so non-intrusive, that they barely touch the particles at all. Yet even the potential for observation, the mere possibility of gaining information about the electron's path, is enough to change its behaviour fundamentally. What makes this even more mysterious is that these quantum effects aren't limited to single particles. Researchers have demonstrated superposition and interference with increasingly complex objects, from atoms and molecules to structures containing hundreds of particles. The boundary between the quantum world and our everyday reality appears to be far more fluid than we once imagined. As you contemplate these ideas, you might notice how they resonate with your own experience in subtle ways. Have you ever had the feeling that your attention itself changes what you observe? That the simple act of focusing on something, whether it's a conversation with a friend or the play of light through your window, somehow transforms the experience itself? This isn't to suggest that human consciousness directly controls quantum events, that remains unproven and scientifically controversial, but rather that the universe appears to be far more interconnected, far more responsive to the act of observation than our classical intuitions would suggest. The mystery deepens when we consider what physicists call quantum entanglement. When two particles become entangled, they remain mysteriously connected regardless of the distance separating them. Measure one particle and you instantly know something about its distant partner, even if they're separated by billions of light years. Einstein famously called this spooky action at a distance, and it troubled him deeply, but experiments have confirmed again and again that entanglement is real. The universe appears to be woven together by invisible threads of connection that transcend our ordinary notions of space and time. When we observe one part of an entangled system, we're not just gaining information about that particular particle, we're participating in a cosmic web of relationships that spans the cosmos. This raises profound questions about the nature of consciousness itself. If observation plays such a fundamental role in determining physical reality, what exactly constitutes an observer? Does it require human consciousness, or is any interaction with the environment sufficient? These questions remain hotly debated among physicists and philosophers, with no clear consensus in sight. Some interpretations of quantum mechanics suggest that consciousness might be more fundamental to reality than we ever imagined. Others propose that what we call observation is simply any interaction that transfers information from one system to another, with consciousness playing no special role at all. But regardless of which interpretation proves correct, the quantum realm reveals a universe far stranger and more mysterious than the clockwork cosmos our ancestors envisioned. We live in a reality where the very act of looking seems to participate in the creation of what is seen, where particles can be in multiple states simultaneously, and where distant objects remain connected by bonds that transcend space and time. As our journey through cosmic impossibility continues, we encounter yet another way in which our universe balanced on the edge of non-existence. This time, our story takes us not to the beginning of time, but to a more subtle and perhaps more unsettling possibility that surrounds us even now. The ground beneath our feet, metaphorically speaking, may not be as solid as it appears. According to some interpretations of modern physics, we might be living in what's called a false vacuum, a state that seems stable but is actually perched precariously on the edge of a cosmic cliff. To understand this concept, imagine a ball sitting in a shallow depression on the side of a hill. The ball appears to be at rest, stable in its little hollow, but it's not in the lowest possible position. A small push could send it rolling down to a much deeper valley below. This is the essence of a false vacuum, a state of apparent stability that could transition to something fundamentally different with the right kind of disturbance. The Higgs field, discovered at the Large Hadron Collider in 2012, provides the mechanism that gives mass to fundamental particles. But measurements of the Higgs boson have revealed something both fascinating and slightly troubling. The mass of this particle places our entire universe in what physicists call a metastable state, balanced between true stability and instability. If our universe is indeed in a false vacuum state, the consequences of a transition to a true vacuum would be unlike anything we can easily imagine. The very constants of nature that make chemistry possible could change. The forces that hold atoms together might weaken or strengthen dramatically. The fundamental particles that compose your body might become unstable or transform into something entirely different. Such a transition would begin as a tiny bubble of true vacuum, perhaps no larger than a proton appearing somewhere in space, but this bubble wouldn't remain small. It would expand in all directions, at the speed of light, its walls carrying tremendous energy and fundamentally altering the physics of everything they touched. You wouldn't see it coming. The wall of this expanding bubble would be invisible, detectable only when it arrived to transform the very nature of matter itself. In one terrifying scenario calculated by physicists, any region of true vacuum would immediately collapse into a black hole, ending not just life, but the possibility of any complex structure whatsoever. The timescales involved in such a transition offer some comfort. If our universe is metastable, the expected lifetime before such a catastrophic change would be vastly longer than the current age of the cosmos. We're talking about periods so immense that the birth and death of countless generations of stars would pass like fleeting moments in comparison. But the very possibility adds another layer to our story of cosmic improbability. Not only did the universe have to navigate the dangers of its birth, surviving the matter-antimatter annihilation and achieving impossible fine-tuning, but it also had to land in a configuration stable enough to persist for billions of years. This metastability might actually be a feature rather than a bug in the cosmic design. Some physicists speculate that a perfectly stable vacuum might be too rigid, too unchanging to allow for the rich complexity we observe. A metastable state, by contrast, permits evolution and change while maintaining enough stability for complex structures to form and persist. As you rest in this moment, consider the layers of improbability that had to align for you to exist. The universe had to survive its violent birth, achieve precise fine-tuning of its fundamental constants, and then maintain a delicate balance between stability and change for nearly 14 billion years. Every breath you take, every heartbeat, every thought that passes through your consciousness depends on this cosmic balancing act continuing for just a little while longer. You are not just a collection of atoms and molecules, but a temporary pattern in a universe that itself might be temporary, a brief flowering of consciousness in a cosmos balanced on the edge of transformation. Our exploration of cosmic impossibility now brings us to the very boundaries of knowledge itself, to horizons beyond which even our most sophisticated theories cannot peer. Here, at the edges of the observable universe, we encounter mysteries that remind us how much we still don't understand about the nature of existence. The universe we can observe, vast as it is, represents only a tiny fraction of what might exist beyond our cosmic horizon. Light from the most distant galaxies has been travelling toward us for nearly the entire age of the cosmos, but there are regions of space whose light will never reach us, no matter how long we wait. These areas are not empty voids, but potentially rich with galaxies, stars, and perhaps even forms of life we can never hope to encounter. This observational limit creates a profound question about the nature of reality itself. If there are parts of the universe we can never observe, never interact with, never confirm exist, what does it mean to say they are real? Do they exist in the same sense that the stars we can see exist, or are they something more like mathematical possibilities, forever beyond the reach of empirical verification? The answer to this question might depend on whether our universe is finite or infinite. If space extends forever in all directions, then there would be an infinite number of regions like our own observable bubble, each containing its own collection of galaxies and stellar nurseries. In such an infinite cosmos, everything that can happen would happen somewhere, including exact or near exact copies of our own solar system, our own planet, even our own lives. This possibility, while scientifically plausible, stretches the imagination to its breaking point. Somewhere in an infinite universe, there might be another version of you, listening to these very words, but perhaps on a planet where the sky's green instead of blue, or where flowers grow in geometric patterns we've never imagined. But infinity brings its own paradoxes and impossibilities. If every possible arrangement of matter occurs somewhere in an infinite universe, then there would be regions where the laws of physics appear to be violated, not because they actually are, but because random fluctuations occasionally create configurations that look miraculous or impossible. The multiverse hypothesis takes these ideas even further, suggesting that our entire observable universe might be just one bubble in an endless cosmic foam, where each bubble has its own laws of physics, its own fundamental constants, its own possibilities for complexity and life. In some of these parallel universes, the strong nuclear force might be slightly different, preventing the formation of complex atoms. In others, gravity might be so weak that stars never form, or so strong that they collapse immediately into black holes. Most of these alternate realities would be sterile, empty places where nothing interesting could ever happen. But in a vast multiverse containing every possible variation, a few universes like ours would inevitably exist. Universes where the constants happen to fall within the narrow ranges necessary for complexity, chemistry, and consciousness to emerge. This multiverse explanation for cosmic fine-tuning remains highly speculative, impossible to test with current technology, and philosophically controversial. Some scientists argue that invoking an infinite number of unobservable universes to explain the properties of the one we can see is no more scientific than invoking supernatural intervention. Others counter that the multiverse hypothesis emerges naturally from our best theories of quantum mechanics and cosmic inflation, and that dismissing it simply because it's unobservable would be like dismissing the existence of the far side of the moon before we had spacecraft capable of photographing it. As you contemplate these vast possibilities, notice how they might shift your sense of place in the cosmos. Are you a unique occurrence in a single, finely tuned universe, or one of countless conscious beings scattered across an infinite multiverse? Does it matter whether your particular arrangement of atoms and thoughts has occurred elsewhere, or is the experience of being you, here and now, sufficient unto itself? These questions have no easy answers, but they remind us that the mystery of existence extends far beyond our immediate experience. The universe that seems so solid and predictable in our daily lives might be just one note in a cosmic symphony of unimaginable scope and complexity. As we near the end of our journey through cosmic impossibility, we encounter what might be the most profound question of all. Given the extraordinary improbability of our universe's existence, given the countless ways it could have failed to form or quickly destroyed itself, how do we make sense of the fact that we're here to contemplate these mysteries at all? This question lies at the heart of what philosophers and scientists call the anthropic principle. In its simplest form, this principle observes that we can only find ourselves in a universe capable of producing observers. If the constants of nature were different, if the early universe had evolved differently, if any of 1,000 cosmic coin flips had landed the other way, we wouldn't be here to notice the difference. This seems almost trivially obvious at first glance, but its implications are far from trivial. The anthropic principle suggests that many of the apparent coincidences and fine-tuning we observe in the universe might not be coincidences at all, but inevitable consequences of the fact that we exist to observe them. Imagine walking into a casino and discovering that every slot machine is showing 3 cherries. You might conclude that the machines are rigged, that someone has carefully arranged this outcome. But if you learned that the casino had billions of slot machines, and that you were only brought into this particular room because all the machines here happen to be showing jackpots, your perspective would change completely. The anthropic principle suggests something similar might be happening with our universe. If there are countless universes or regions of space with different physical constants, we should not be surprised to find ourselves in one of the rare regions where the constants allow for complexity and consciousness to emerge. But this explanation, while logically sound, raises new questions that are perhaps even more puzzling than the ones it attempts to answer. If we exist only because we happen to find ourselves in a universe capable of producing observers, what does this say about the nature of consciousness itself? Is our ability to contemplate these questions merely an accident of cosmic evolution, or does awareness play a more fundamental role in the structure of reality? Some interpretations of quantum mechanics suggest that consciousness might be more than just a byproduct of complex chemistry. If observation plays a role in determining physical reality, as the quantum experiments seem to suggest, then perhaps consciousness and cosmos are more deeply intertwined than we ever imagined. This remains highly speculative, with no scientific consensus, but it points toward a possibility that would transform our understanding of existence itself. Rather than being accidental observers in a universe that happened to develop the right conditions for awareness, we might be participants in a cosmic process where mind and matter, observer and observed, are aspects of a deeper unity. As you sit with these ideas, notice how they might change your sense of your own significance. In a universe of billions of galaxies, each containing billions of stars, it's easy to feel small and insignificant. But if consciousness plays any role at all in the unfolding of reality, then your awareness, your ability to contemplate these mysteries might be far more important than the vast scales of space and time would suggest. You are not just a temporary arrangement of atoms that happen to achieve self-awareness. You are the universe becoming conscious of itself, a focal point where cosmic evolution has produced the capacity for wonder, curiosity, and understanding. As we venture further into the quantum realm, we encounter what physicists call the measurement problem, a puzzle so fundamental that it challenges our most basic assumptions about the nature of reality itself. It's a mystery that begins with the simple act of observation and leads us into philosophical territory that would have seemed like pure fantasy to scientists just a century ago. In the classical world we experience every day, objects have definite properties, whether we're looking at them or not. A coin lying on your desk is either heads or tails, a book is either open or closed, the moon continues its orbit, whether anyone is watching or not. But quantum mechanics suggests that at the smallest scales, this intuitive picture breaks down completely. According to the mathematics of quantum theory, particles exist in what physicists call superposition states, simultaneously embodying multiple contradictory properties until the moment they're measured. An electron doesn't just have an unknown spin direction, it literally spins in all possible directions at once. A photon doesn't simply follow an unknown path through space, it travels every possible route, simultaneously. This isn't merely a limitation of our knowledge or our instruments. The theory suggests that these multiple states are genuinely real until the act of measurement forces reality to make a choice. It's as if the universe remains fluid and undetermined until consciousness turns its attention toward it, at which point the wave of possibilities collapses into a single, definite outcome. But here's where the mystery deepens into something that might keep philosophers awake at night. What exactly constitutes a measurement? When does the collapse happen? And perhaps most puzzling of all, why does the act of observation seem to play such a special role in determining what becomes real? Consider the famous thought experiment known as Schrödinger's cat, where a feline in a sealed box is both alive and dead until someone opens the box to look. While this scenario was originally proposed to highlight the apparent absurdity of quantum mechanics when applied to everyday objects, it captures something profound about the relationship between observation and reality. Some interpretations suggest that consciousness itself might play a fundamental role in the collapse of quantum states. Others propose that any interaction with the environment, whether observed by a conscious being or not, is sufficient to determine outcomes. Still others suggest that all possible outcomes occur simultaneously in parallel universes, with consciousness simply selecting which branch of reality it experiences. As you contemplate these possibilities, notice how they might resonate with moments in your own life when the act of paying attention seemed to change the very thing you were observing. Have you ever had the experience of watching a sunset and feeling as though your attention somehow participated in creating the beauty you witnessed? While this remains scientifically unproven, these quantum mysteries suggest that the relationship between observer and observed might be far more intimate than our everyday experience would suggest. The measurement problem extends far beyond laboratory experiments with individual particles. Some researchers have proposed that consciousness and quantum mechanics might be connected in ways we're only beginning to understand. While no scientific consensus exists on this topic, the questions it raises about the nature of awareness and reality continue to inspire both rigorous research and profound philosophical contemplation. What emerges from these investigations is a picture of a universe far more participatory far more responsive to the act of observation than the mechanical cosmos our ancestors envisioned. We might not be passive witnesses to a predetermined reality, but active participants in an ongoing process of creation and discovery. Our journey through cosmic impossibility now brings us to another puzzle that strikes at the very foundations of physics itself. This mystery concerns not what exists, but what doesn't exist in the overwhelming abundance that our theories predict it should. Deep within the mathematical structure of reality lies what physicists call the hierarchy problem, a discrepancy so profound that it suggests we're missing something fundamental about how the universe works. The problem centers on the Higgs field, that invisible presence that permeates all of space and gives mass to the fundamental particles. According to our best calculations, the Higgs field should be subject to quantum corrections so enormous that its mass should be trillions of times larger than what we actually observe. These corrections arise from the constant dance of virtual particles that populate even empty space, each one contributing to the total energy and mass of the Higgs field. If these corrections were allowed to run unchecked, the Higgs boson should be so massive that it would destabilize the entire structure of matter. Atoms would be torn apart, chemistry would become impossible, and the universe would collapse into a state of unimaginable density. Yet somehow, miraculously, these potentially catastrophic corrections are almost perfectly cancelled out, leaving behind a Higgs field with exactly the right mass to make our existence possible. The precision required for this cancellation is breathtaking. Imagine trying to balance two enormous numbers, each containing hundreds of digits, so that their difference equals exactly 125.1, the measured mass of the Higgs boson in the appropriate units. The slightest error in any of those hundreds of digits would throw off the entire calculation and make stable matter impossible. This extraordinary fine-tuning suggests that either we live in a universe of impossible coincidences, or there's some deeper principle at work that we haven't yet discovered. Some theorists have proposed elegant solutions involving new symmetries in nature, while others suggest that we might be living in one of countless universes where the constants just happen to work out correctly. But perhaps the most intriguing possibility is that the apparent fine-tuning reveals something profound about the relationship between mind and cosmos. While no scientific consensus exists on this interpretation, some researchers have wondered whether consciousness itself might play a role in selecting the physical constants that allow for complex, aware beings to exist. Take a moment to consider the implications of this mystery. Every atom in your body, every molecule that makes up your DNA, every chemical reaction that sustains your life, depends on the Higgs field having exactly the right mass. If it were even slightly different, you wouldn't just be unable to exist, the very concept of stable matter would be meaningless. You are composed of particles whose masses are determined by their interaction with a field that, according to our best theories, shouldn't have the properties necessary to make your existence possible. Yet here you are, breathing, thinking, contemplating these very mysteries that shouldn't allow for the existence of contemplation itself. As our exploration continues, we encounter yet another way in which the universe defies our expectations about how reality should behave. This time, our story takes us to the event horizons of black holes, those mysterious regions where space and time become so warped that even light cannot escape. For decades, physicists believed they understood the basic properties of black holes. These cosmic monsters devour everything that comes too close, growing larger and more massive with each meal, seemingly destined to persist forever as the ultimate gravitational prisons. But in the 1970s, Stephen Hawking made a discovery that revolutionized our understanding of these enigmatic objects and revealed another fundamental paradox in the nature of existence. Hawking showed that black holes should slowly evaporate by emitting radiation, gradually losing mass and energy until they disappear completely. This process occurs through a quantum mechanical effect near the event horizon, where virtual particle pairs are created from the vacuum, and one member of each pair falls into the black hole while the other escapes as real radiation. At first glance, this discovery seemed to solve one mystery while creating another. If black holes evaporate completely, what happens to all the information that fell into them over their lifetimes? In quantum mechanics, information is never truly destroyed. It can be scrambled and hidden, but it must always be preserved in some form. Yet Hawking radiation appears to be completely random, carrying no trace of the information that originally fell into the black hole. This information paradox has profound implications for our understanding of reality itself. If information can truly be destroyed, then the fundamental laws of physics as we understand them are incomplete or incorrect. The universe would be far stranger and more unpredictable than we ever imagined. Various solutions have been proposed to resolve this paradox, each more mind-bending than the last. Some suggest that the information is preserved but encoded in the Hawking radiation in ways so subtle that we haven't yet learned how to detect it. Others propose that black holes don't evaporate completely, but leave behind tiny remnants that preserve all the information they once contained. Perhaps the most radical solution suggests that the information never falls into the black hole at all, but remains encoded on its surface in a kind of holographic projection. In this view, the three-dimensional space we experience might itself be a kind of hologram, with all the information in any region of space encoded on its two-dimensional boundary. This holographic principle, if correct, would revolutionize our understanding of space, time, and information itself. Reality might be far more interconnected and information-rich than we ever suspected, with every part containing encoded information about the whole. As you sit with these ideas, consider how they might change your perspective on the nature of your own existence. If the holographic principle is correct, then the information that makes you who you are, your memories, your thoughts, your unique pattern of consciousness, might be preserved in the very structure of space-time itself. The universe might not just be a collection of particles and forces, but a vast information processing system where consciousness and cosmos are intimately connected. While this remains highly speculative, with no scientific consensus, it points toward possibilities that would transform our understanding of what it means to exist, to think, and to participate in the ongoing evolution of reality. Our journey through impossible physics now brings us to one of the most mysterious and philosophically intriguing phenomena in quantum mechanics. The quantum Zeno effect, named after the ancient Greek philosopher who proposed paradoxes about motion and time, reveals that the simple act of observation can literally freeze quantum systems in place. In the classical world, watching something doesn't change its behavior. You can observe a rolling ball or a falling leaf without affecting their motion in any measurable way. But in the quantum realm, continuous observation can prevent a system from evolving entirely, trapping it in whatever state it was in when the observation began. This isn't science fiction or philosophical speculation. Researchers have demonstrated the quantum Zeno effect in carefully controlled laboratory experiments. When they observe a quantum system frequently enough, they can effectively stop its evolution, preventing it from transitioning to new states even when such transitions would normally be inevitable. The mechanism behind this effect lies in the fundamental nature of quantum measurement. Each time a quantum system is observed, its wave function collapses back to a definite state. If these measurements happen frequently enough, the system never has time to evolve into new superposition states. It's as if reality is constantly being reset to its initial configuration by the act of observation itself. This discovery has profound implications for our understanding of the relationship between consciousness and cosmos. While no scientific consensus exists on whether human awareness plays a special role in quantum mechanics, the Zeno effect demonstrates that observation, in the technical sense of information extraction, can have dramatic effects on physical reality. Some interpretations suggest that this phenomenon might extend beyond the quantum realm in ways we don't yet fully understand. If attention and awareness have the power to influence the evolution of physical systems, even in subtle ways, then consciousness might play a more active role in shaping reality than we ever imagined. Take a breath and consider how this might relate to your own experience of attention and awareness. Have you ever noticed that focusing intensely on a particular aspect of your life seems to amplify or stabilize it in unexpected ways? While any such connection to the quantum Zeno effect remains purely speculative, these discoveries remind us that the relationship between mind and matter might be far more intimate than classical physics would suggest. The quantum Zeno effect also raises questions about the nature of time itself. If observation can freeze quantum evolution, then the flow of time at the microscopic level might be more flexible and observer-dependent than we typically assume. Reality might not unfold according to a universal clock, but rather through a complex dance between quantum possibilities and the observations that collapse them into definite outcomes. As you contemplate these ideas, notice how they might shift your understanding of your own role as an observer in the cosmos. Rather than being a passive witness to predetermined events, you might be a participant in an ongoing process of reality creation, where the simple act of paying attention contributes to determining what becomes real. This remains a deeply mysterious and controversial area of physics, with many unanswered questions and competing interpretations. But the very existence of the quantum Zeno effect reminds us that we live in a universe far stranger and more participatory than our everyday experience would suggest. As we continue our exploration of cosmic impossibility, we encounter another mystery that challenges our understanding of how complex, organized structures can arise from apparent randomness and chaos. This phenomenon, known as emergence, represents one of the most beautiful and puzzling aspects of natural systems. Consider the extraordinary fact that you exist at all. You are composed of trillions of individual atoms, each one following the basic laws of chemistry and physics. Yet somehow their collective behavior gives rise to consciousness, creativity, and the capacity for wonder. No single atom in your body is aware, yet their organized interaction creates the rich inner life you experience every moment. This emergence of mind from matter represents one of the deepest mysteries in science. How do unconscious particles, following blind physical laws, give rise to subjective experience? How does the universe become aware of itself through arrangements of matter like you? The same puzzle appears at every level of organization in nature. Individual neurons in your brain are not conscious, yet their Collective activity creates thoughts, emotions, and memories. Single cells in your body have no awareness of your plans or dreams, yet they work together seamlessly to maintain the complex biological processes that keep you alive. This emergence of higher-order properties from simpler components seems to violate our intuitive expectations about how cause and effect should work. We typically expect that to understand a complex system, we need only understand its individual parts. But emergent phenomena suggest that the whole can be qualitatively different from the sum of its parts. The emergence of life itself represents perhaps the most striking example of this phenomenon. Billions of years ago, simple molecules in Earth's primordial oceans somehow organized themselves into self-replicating systems capable of evolution and adaptation. From purely chemical processes arose the first glimmers of what we might recognize as purposeful behavior. But emergence isn't limited to biological systems. It appears throughout the cosmos, from the formation of galaxies, from clouds of gas and dust to the crystallization of snowflakes from water vapor. Everywhere we look, we find examples of complex organized structures arising from simpler components through processes that seem almost magical in their creativity. Some researchers have suggested that consciousness itself might be an emergent property of sufficiently complex information processing systems. In this view, awareness isn't something added to the universe from outside, but rather a natural consequence of matter organizing itself in certain ways. If this interpretation is correct, then consciousness might be as fundamental a feature of reality as mass or electric charge. The universe might not have developed the capacity for awareness accidentally, but rather consciousness might be an inevitable consequence of cosmic evolution, emerging wherever matter achieves sufficient complexity and organization. As you reflect on these ideas, consider the profound mystery of your own emergence from simpler components. The atoms that make up your body were forged in the nuclear furnaces of ancient stars, scattered through space when those stars died, and eventually incorporated into the Earth, and then into the biological processes that created you. You are not separate from the cosmos, but rather a temporary pattern in its ongoing evolution, a place where the universe has achieved the remarkable feat of becoming aware of itself. Your thoughts, your emotions, your capacity to contemplate these very mysteries represent the latest chapter in a cosmic story of emergence that began with the first stirrings of complexity in the early universe. Take a moment to appreciate the extraordinary improbability of this process. Through countless accidents and coincidences, through the precise fine-tuning of fundamental constants and the survival of matter through cosmic catastrophes, the universe has managed to create conscious beings capable of understanding something about their own nature and origins. As our exploration of cosmic impossibility deepens, we arrive at perhaps the most profound mystery of all, one that brings together everything we've discovered about the strange nature of reality and focuses it into a single penetrating question. How does subjective experience arise from objective matter? How does the universe become aware of itself through arrangements of particles that seem to have no awareness of their own? This is what philosophers call the hard problem of consciousness, and it represents the ultimate frontier in our understanding of existence itself. We can explain the functional aspects of consciousness, how brains process information, store memories, and coordinate behavior. But the subjective, felt experience of being aware, what philosophers call qualia, remains deeply mysterious. Consider the redness you experience when looking at a rose, the particular quality of sadness that accompanies loss, or the sense of wonder you might feel contemplating these cosmic mysteries. These subjective experiences seem to have properties that don't obviously emerge from the objective, measurable properties of neurons and synapses. The mystery deepens when we consider that consciousness appears to be intimately connected to many of the quantum puzzles we've explored. The measurement problem in quantum mechanics remains unsolved, partly because we don't fully understand the relationship between observation and physical reality. Some interpretations suggest that consciousness might play a fundamental role in determining which quantum possibilities become actual. While no scientific consensus exists on this connection, the parallels are intriguing. Both consciousness and quantum measurement seem to involve the selection of specific outcomes from broader ranges of possibility. Both appear to create definite reality from indefinite potential. Both suggest that the universe might be far more participatory and observer-dependent than classical physics assumed. Recent research in neuroscience has revealed that consciousness might be more quantum-like than we previously suspected. Some studies suggest that certain aspects of brain function, particularly processes related to attention and awareness, might involve quantum coherence effects similar to those we see in quantum computers. This remains highly speculative, with ongoing debate about whether quantum effects could persist in the warm, noisy environment of the brain. But the possibility that consciousness might literally be a quantum phenomenon adds another layer to our story of cosmic impossibility. If consciousness does involve quantum processes, then every moment of your awareness might be connected to the fundamental quantum nature of reality itself. Your thoughts and experiences wouldn't be separate from the quantum dance of particles and possibilities, but direct expressions of the same mysterious processes that govern the microscopic world. Take a gentle breath and consider how this might change your sense of your place in the cosmos. Rather than being an accidental observer in a mechanical universe, you might be an integral part of the cosmic process through which reality creates and experiences itself. Your consciousness, your capacity to contemplate these mysteries, might not be a mere byproduct of complex chemistry, but a fundamental feature of a universe that is inherently aware, inherently creative, inherently participatory. While this interpretation remains unproven and controversial, it points toward a vision of existence that is both humbling and empowering. The hard problem of consciousness reminds us that despite all our scientific advances, we still don't understand the most basic fact of our existence, that we exist as aware beings in an apparently impossible universe. This ignorance isn't a failure of science, but perhaps its greatest gift, a reminder that mystery and wonder remain at the very heart of existence. As we approach the conclusion of our journey through cosmic impossibility, consider how these insights might transform your daily experience. If consciousness is indeed fundamental to reality, then every moment of awareness is an opportunity to participate in the ongoing creation of the cosmos. Your attention, your curiosity, your capacity for wonder might not be accidents of evolution, but expressions of the universe's inherent drive toward greater complexity, beauty, and understanding. In choosing to contemplate these mysteries, you are participating in the cosmic process through which existence comes to know itself. Our journey through the impossible now brings us to the very frontier of what science can tell us about the nature of existence itself. Here, at the intersection of quantum mechanics and cosmic mystery, we discover that the universe operates on principles so strange so counterintuitive that they challenge every assumption we've ever made about the relationship between possibility and reality. In the quantum realm, the very concept of probability takes on meanings that would have seemed absurd to scientists just a century ago. When we observe a quantum particle, we're not simply revealing a pre-existing property that was hidden from view. Instead, we appear to be participating in a process where multiple potential realities collapse into a single, definite outcome. This isn't merely a technical detail about how measurements work. It suggests something profound about the nature of reality itself. The universe, at its most fundamental level, seems to exist in a state of perpetual potential until the moment when observation transforms possibility into actuality. Consider how this might relate to the broader mystery of why anything exists at all. If quantum mechanics is correct, then the transition from nothingness to something might not require a traditional cause in the way we usually think about causation. Instead, existence itself might emerge from the quantum foam of possibility that underlies all of reality. Some interpretations of quantum field theory suggest that even empty space is never truly empty, but seethes with virtual particles constantly appearing and disappearing. These quantum fluctuations might provide a mechanism through which something can indeed emerge from nothing, not through divine intervention or miraculous coincidence, but through the fundamental probabilistic nature of reality itself. As you contemplate this possibility, notice how it might shift your understanding of your own existence. You might not be here because of a specific chain of causes stretching back to the beginning of time, but rather because you represent one of countless potential patterns that the quantum universe is constantly exploring. This perspective doesn't diminish your significance, but rather places you at the center of one of the most profound mysteries in all of science. You are not just a product of cosmic evolution, but a conscious expression of the universe's capacity to transform possibility into reality through the simple act of observation and awareness. Take a gentle breath and let yourself feel the weight of this mystery. Every quantum interaction, every collapse of a wave function, every moment when possibility becomes actuality, represents a tiny miracle of existence emerging from the vast sea of what could be. The mathematics of quantum mechanics can predict the probabilities of these events with extraordinary precision, but it cannot tell us why any particular outcome occurs rather than its alternatives. This gap between predictable probabilities and actual events might be where consciousness enters the cosmic story, not as a controller of quantum events, but as a participant in the ongoing dance between possibility and reality. As we delve deeper into the mystery of impossible existence, we encounter what philosophers call the bootstrap paradox, a logical puzzle that appears to describe the very foundation of reality itself. This paradox asks a deceptively simple question: what caused the cause of everything? In our everyday experience, we're accustomed to chains of causation that stretch backward through time. Your existence depends on your parents, who depended on their parents, and so on through countless generations. The Earth formed from a disk of dust and gas around the young sun, which condensed from clouds of material created by earlier generations of stars. Each event seems to require a prior cause to explain it. But when we trace these causal chains back to their ultimate origins, we run into a fundamental problem. What caused the Big Bang? What existed before the beginning of space and time? How can something emerge from nothing without violating the principle that every effect must have a cause? Some cosmological models suggest that our universe might be part of an eternal cycle, where each cosmic death gives birth to a new cosmos. Others propose that time itself might be circular, with effects becoming their own causes in a loop that has no beginning or end. Still others suggest that the entire concept of causation might break down at the quantum level, where events can occur without traditional causes. The bootstrap paradox appears not only in cosmology, but in the quantum realm as well. Virtual particles seem to borrow energy from the vacuum and then pay it back so quickly that the debt never comes due. The Casimir effect demonstrates that this borrowing has real, measurable consequences, suggesting that the universe operates on a kind of cosmic credit system where effects can precede their causes. This temporal flexibility extends to quantum entanglement as well, where measurements made in the present can seem to influence events that occurred in the past. While no information travels faster than light, the correlations between entangled particles suggest that the universe might be fundamentally non-local, with connections that transcend our ordinary notions of space and time. As you reflect on these ideas, consider how they might apply to your own existence. The atoms in your body were created in stellar furnaces billions of years ago, yet those same atoms are now contemplating their own origins through your consciousness. In a very real sense, the universe is using matter it created in the past to understand itself in the present, creating a kind of bootstrap loop where effect and cause become indistinguishable. This circular relationship between mind and cosmos suggests that consciousness might not be an accidental byproduct of material complexity, but rather an integral part of the cosmic process through which existence comes to understand itself. While this remains highly speculative, with no scientific consensus, it points toward a universe that is inherently self-referential and self-creating. The bootstrap paradox reminds us that the deepest questions about existence might not have answers in the traditional sense. Instead of seeking ultimate causes or final explanations, we might need to embrace the mystery of a universe that creates itself through the very act of existing, where consciousness and cosmos participate in an eternal dance of mutual creation and discovery. Our exploration of cosmic impossibility now leads us to one of the most counterintuitive phenomena in quantum mechanics, a process that might explain not just how particles can pass through barriers, but how existence itself might have tunneled into being from nothingness. Quantum tunneling represents a direct violation of our classical intuitions about how reality should work. In the everyday world, if you don't have enough energy to climb over a hill, you simply can't reach the other side. But in the quantum realm, particles can pass through energy barriers even when they lack the energy needed to surmount them classically. This isn't just a theoretical curiosity. Quantum tunneling powers the fusion reactions that make stars shine, enables the radioactive decay that helps heat the Earth's interior, and makes possible many of the electronic devices we depend on daily. Without tunneling, the universe would be a cold, dark place, where nuclear fusion never occurred and complex chemistry never developed. But perhaps most remarkably, some cosmological models suggest that the universe itself might have tunneled into existence from a state of pure nothingness. In these scenarios, the Big Bang wasn't triggered by a specific cause, but rather emerged as a quantum tunneling event, where existence spontaneously appeared from the vacuum of non-being. This possibility challenges our deepest assumptions about the relationship between something and nothing. If quantum tunneling can allow particles to pass through impossible barriers, perhaps it can also allow entire universes to tunnel into existence from states where no energy, no matter, no space, and no time exists at all. The mathematics supporting this idea are complex and highly speculative, but they suggest that the probability of a universe tunneling into existence, while incredibly small, is not zero. In the strange logic of quantum mechanics, anything that has a non-zero probability will eventually occur, given enough time or enough opportunities. Take a moment to consider the profound implications of this possibility. If our universe did indeed tunnel into existence from nothingness, then every atom in your body, every thought in your mind, every star in the sky represents a quantum miracle of the highest order. You would not just be unlikely, you would be impossible according to classical physics. Yet here you are, a living testament to the mysterious power of quantum processes to transcend the boundaries of what should be possible. Your very existence would represent the universe's capacity to create something from nothing through the subtle dance of quantum probability. As you breathe in this moment, imagine that each breath might be part of a cosmic tunneling process, where consciousness itself passes through the barrier between non-existence and existence, between unconscious matter and aware being. While this remains purely metaphorical, it captures something essential about the mysterious nature of awareness in a quantum universe. The phenomenon of quantum tunneling reminds us that the impossible happens constantly at the microscopic level, and perhaps this impossibility extends all the way up to the largest scales of existence. We might be living inside a cosmic tunneling event, temporary residents of a universe that borrowed its existence from the quantum vacuum and hasn't yet been required to pay it back. As we continue our gentle journey through the mysteries that surround us, we encounter what might be the most philosophically challenging aspect of quantum mechanics: the role of observation in determining what becomes real. This phenomenon, known as the observer effect, suggests that the universe might be far more participatory than we ever imagined. In classical physics, the act of observation was considered passive. You could watch a planet orbit the sun or measure the temperature of a cup of tea without significantly affecting what you were studying. The universe was seen as an objective reality that existed independently of anyone's knowledge or attention. But quantum mechanics reveals a very different picture. At the subatomic level, the act of measurement doesn't simply reveal pre-existing properties, it appears to participate in creating them. Before measurement, a quantum particle exists in a superposition of all possible states. Only when observed does it choose a specific outcome from the range of possibilities. This isn't due to clumsy measuring instruments, disturbing delicate quantum systems. Even the most gentle, non-invasive measurements still cause wave functions to collapse and force reality to make definite choices from indefinite possibilities. Some interpretations of quantum mechanics suggest that consciousness might play a special role in this process. Though no scientific consensus exists on this controversial topic, other interpretations propose that any interaction capable of extracting information, whether observed by a conscious being or not, is sufficient to collapse quantum states. Regardless of which interpretation proves correct, the observer effect reveals something profound about the nature of existence itself. Reality appears to be fundamentally interactive, responsive to the very act of investigation. The universe doesn't simply exist to be discovered, it seems to participate actively in its own revelation. Consider how this might relate to your own experience of consciousness and attention. Have you ever noticed that the simple act of paying close attention to something seems to change it in subtle ways? While any connection to quantum mechanics remains speculative, this everyday experience of participatory awareness might reflect something deep about the relationship between mind and reality. As you sit with these ideas, notice how your attention moves from thought to thought, from sensation to sensation. In quantum mechanics, measurement is often described as a kind of question posed to nature, with the collapse of the wave function representing nature's response. Perhaps consciousness operates in a similar way, constantly asking implicit questions of reality and receiving answers in the form of experience. The observer effect also suggests that knowledge and reality might be more intimately connected than we usually assume. In classical physics, learning about the world was seen as a process of discovering facts that existed independently of our knowledge. But quantum mechanics hints that the act of knowing might participate in creating what is known. This doesn't mean that human thoughts directly control quantum events. Such claims remain unproven and scientifically controversial. Rather, it suggests that the universe might be inherently informational, structured more like a vast interactive computation than a mechanical clockwork. Take a gentle breath and consider how this perspective might change your sense of your place in the cosmos. Rather than being a passive observer of predetermined events, you might be an active participant in an ongoing process of cosmic self-discovery, where the universe comes to know itself through consciousness like yours. Our exploration of impossible existence now brings us to one of the most counterintuitive discoveries in modern physics: the revelation that empty space is actually full of activity, energy, and possibility. What we call the quantum vacuum represents not nothingness, but rather the ground state of everything. This discovery overturns thousands of years of thinking about the nature of emptiness. Ancient philosophers debated whether a true vacuum could exist, but they imagined it as a region of absolute nothingness, devoid of matter, energy, and activity. Quantum mechanics reveals that such perfect emptiness is actually impossible. Even when we remove all particles from a region of space and cool it to absolute zero, the quantum vacuum continues to seethe with activity. Virtual particles constantly appear and disappear, borrowing energy from the vacuum and returning it so quickly that they never quite violate the conservation laws. This isn't just a mathematical abstraction. These fluctuations have measurable effects on the physical world. The Casimir effect demonstrates this beautifully. When two metal plates are placed extremely close together in a vacuum, the quantum fluctuations between them are restricted, while those outside remain unrestricted. This creates a measurable force that pushes the plates together, proving that empty space itself carries energy and momentum. These discoveries suggest that the vacuum might be better understood not as emptiness, but as a kind of cosmic potential, a reservoir of possibility from which particles and even entire universes might emerge. Some cosmological models propose that our Big Bang itself emerged from a quantum fluctuation in a pre-existing vacuum, a spontaneous crystallization of energy and space-time from the underlying quantum foam. As you contemplate this idea, consider how it might change your understanding of solitude and silence. When you sit quietly in meditation or simply rest in a moment of stillness, you might think you're experiencing emptiness, but quantum mechanics suggests that even the most perfect silence is alive with subtle activity, humming with possibilities that exist just below the threshold of perception. This perspective transforms emptiness from absence into presence, from nothing into everything in potential. The spaces between thoughts, the gaps between breaths, the moments of quiet contemplation might all be filled with the same quantum potential that underlies all of reality. The vacuum's creative potential extends beyond just the appearance of virtual particles. Some theories suggest that consciousness itself might emerge from the quantum properties of space, that awareness might be a fundamental feature of the vacuum state rather than something that arises only in complex biological systems. While this remains highly speculative, with no scientific consensus, it points toward a universe where mind and matter might be different aspects of the same underlying quantum reality. The stillness you experience in deep contemplation might connect you directly to the creative source from which all existence continuously emerges. Take a moment to rest in this possibility. As you breathe, imagine that each inhalation draws in not just air, but the quantum potential of empty space itself. Each exhalation might release not just carbon dioxide, but your own small contribution to the cosmic field of possibility that surrounds and interpenetrates everything. The quantum vacuum reminds us that nothingness and everything might be more closely related than we ever imagined. In the deepest emptiness lies infinite potential. In the most perfect silence resonates the possibility of all sounds. In the apparent absence of everything exists the presence of all that could be. As we venture deeper into the mysteries of quantum reality, we encounter experiments so strange that they challenge our most basic assumptions about the relationship between past, present, and future. These delayed choice experiments suggest that the history of the universe might be far more fluid and participatory than we ever dared imagine. The concept is deceptively simple, yet profoundly unsettling. In these experiments, physicists set up quantum systems where they can choose how to measure a particle after it has already completed its journey. Yet this future choice seems to determine what happened to the particle in the past. Imagine light travelling from a distant star, taking millions of years to reach Earth. Along the way, it encounters a massive galaxy that acts as a gravitational lens, potentially splitting the light's path around both sides of the galaxy. When the light finally arrives at our telescopes, we can choose whether to measure it as a wave, which would reveal interference between the two paths, or as a particle, which would show that it took one definite route. The remarkable discovery is that our choice of measurement, made millions of years after the light passed the galaxy, seems to determine retroactively whether the light behaved as a wave or particle during its ancient journey. It's as if the present can reach backward through time to influence the past. This doesn't violate relativity or allow for communication with the past in the science fiction sense. No information travels faster than light, and no causal paradoxes are created. Instead, these experiments reveal something profound about the nature of reality itself. The universe might not have a definite history until that history is observed. Some interpretations suggest that all possible histories exist simultaneously in a quantum superposition until the moment of measurement collapses them into a single, definite timeline. In this view, the past is not fixed and immutable, but remains fluid and probabilistic until consciousness turns its attention towards it. As you reflect on this possibility, consider how it might relate to your own experience of memory and personal history. The stories you tell about your past, the meaning you extract from your experiences, might not simply describe what happened, but participate in creating the significance of what happened. While any direct connection to quantum mechanics remains speculative, there's something profound about the idea that consciousness might play a role in crystallizing not just future possibilities, but past actualities as well. The act of remembering might be more creative than we typically assume, not just retrieving information, but participating in the ongoing creation of personal meaning and identity. The delayed choice experiments also suggest that the boundary between observer and observed might be far more permeable than classical physics assumed. If our present choices can influence past events, then we might be more intimately connected to the cosmos than we ever imagined. The universe might not be a collection of separate objects and events, but a unified, participatory process where consciousness and cosmos co-create reality together. Take a gentle breath and consider how this perspective might change your relationship to time itself. Rather than being carried along by the flow of time from past to future, you might be an active participant in an ongoing process where past, present, and future continuously influence each other through the mysterious mechanisms of quantum correlation and observation. These experiments remind us that the universe is under no obligation to conform to our everyday intuitions about how reality should work. Time might be far more flexible, history far more participatory, and consciousness far more fundamental than we ever suspected. Our journey through cosmic impossibility now brings us to the very edge of life itself, where quantum mechanics meets biology in ways that challenge our understanding of what it means to be alive in an apparently impossible universe. Recent discoveries suggest that life might not just depend on quantum effects, but might actively harness them in ways we're only beginning to understand. For decades, scientists assumed that biological systems were too warm, too wet, and too chaotic to maintain the delicate quantum coherence required for quantum effects to play any significant role. The quantum world seemed to belong to sterile laboratories and carefully controlled experiments, far removed from the messy complexity of living systems. But this assumption is proving to be spectacularly wrong. Researchers have discovered quantum coherence in photosynthesis, the process by which plants convert sunlight into chemical energy. Rather than energy bumbling randomly through the molecular machinery of chloroplasts, it appears to explore multiple pathways simultaneously, finding the most efficient route through quantum superposition. This discovery suggests that evolution might have discovered quantum mechanics billions of years before human physicists did, learning to harness the strange properties of superposition and entanglement to optimize the fundamental processes of life. Plants might literally be quantum computers using the coherent properties of quantum states to achieve near-perfect efficiency in energy transfer. Similar quantum effects have been proposed to explain other biological mysteries. The remarkable navigation abilities of migratory birds might depend on quantum entanglement in specialized proteins in their eyes, allowing them to literally see the Earth's magnetic field. The extraordinary sensitivity of human olfaction might involve quantum tunneling effects that allow us to distinguish between molecules based on their vibrational frequencies. Even more speculatively, some researchers have wondered whether consciousness itself might be a quantum phenomenon, arising from coherent quantum processes in the microtubules of brain cells. While this remains highly controversial, with no scientific consensus, it suggests that awareness might be intimately connected to the same quantum principles that govern the microscopic world. As you contemplate these possibilities, notice how they might change your sense of your relationship to the quantum realm. Rather than being a classical being living in a quantum universe, you might be a quantum system that has learned to experience itself as classical, a coherent pattern of quantum processes that has achieved self-awareness. Take a breath and consider that the oxygen entering your lungs might have been processed by quantum coherent photosynthesis in the leaves of distant trees. The very act of breathing might connect you to a vast network of quantum processes that span the biosphere, linking you through invisible quantum correlations to every living system on Earth. This perspective transforms the relationship between life and physics from one of mere dependence to one of active participation. Rather than simply obeying the laws of quantum mechanics, life might be using those laws creatively, exploring the space of quantum possibilities to find novel solutions to the challenges of existence. The quantum coherence of life also adds another layer to our story of cosmic impossibility. Not only did the universe have to achieve the precise fine-tuning necessary for atoms and molecules to exist, but it also had to allow for the maintenance of quantum coherence in warm, complex biological systems. The fact that such coherence is possible at all represents another miracle of cosmic precision. If consciousness is indeed connected to quantum processes, then every moment of your awareness might be a direct expression of the same mysterious principles that govern reality at its most fundamental level. Your thoughts, your experiences, your capacity to contemplate these mysteries might not be separate from the quantum dance of particles and possibilities, but integral expressions of it. This remains a speculative idea, not a proven scientific fact, but it points toward a vision of existence where mind and matter, consciousness and cosmos, observer and observed, are different aspects of a single, unified quantum reality. In choosing to explore these mysteries, you are participating in the universe's ongoing attempt to understand itself through quantum processes that make understanding itself possible. As our exploration of impossible existence draws toward its contemplative conclusion, we encounter perhaps the most mind-expanding possibility of all: the idea that our universe might be just one garden in an infinite landscape of cosmic possibilities, each with its own unique laws, constants, and potential for complexity and consciousness. This concept, known as the anthropic landscape, emerges from the intersection of cosmology, quantum mechanics, and string theory. It suggests that the apparent fine-tuning of our universe's physical constants might not be a miraculous coincidence or evidence of design, but rather a natural consequence of existing in a multiverse where all possible values of these constants are explored. Imagine an infinite library containing every possible book, including books with every possible variation, in every word, every letter, every punctuation mark. Most of these books would be meaningless gibberish, random arrangements of symbols that convey no information or beauty, but hidden among the vast collection of nonsense would be works of profound wisdom and breathtaking poetry, stories that capture the deepest truths about existence and consciousness. The anthropic landscape suggests something similar about the cosmos. In an infinite multiverse, most universes would be sterile places where the constants of nature don't allow for the formation of atoms, stars, or any complex structures. But scattered throughout this vast collection of failed realities would be rare universes like ours, where the constants happen to fall within the narrow ranges that permit complexity, chemistry, and consciousness to emerge. We find ourselves in one of these rare, habitable universes, not because of any special design or cosmic purpose, but simply because only such universes can produce observers capable of contemplating their own existence. It's a kind of cosmic selection bias. We can only observe universes that are capable of producing observers. This perspective transforms the question of cosmic fine-tuning from "why is our universe so precisely calibrated for life?" to "why shouldn't we find ourselves in a universe capable of supporting life?" Doraized, the apparent improbability of our existence becomes not a puzzle to be solved, but an inevitable consequence of the anthropic principle. But the anthropic landscape raises profound questions about the nature of consciousness and identity. If there are countless versions of you scattered across the multiverse, each living slightly different lives in universes with slightly different physical laws, which one is the real you? Are you somehow connected to your alternate selves through quantum entanglement or other mysterious mechanisms? Some interpretations of quantum mechanics, particularly the many worlds interpretation, suggest that every quantum measurement splits reality into multiple branches, creating new versions of the universe and everyone in it. In this view, you're constantly branching into countless parallel selves, each experiencing a different sequence of quantum outcomes. As you contemplate this possibility, notice how it might affect your sense of uniqueness and significance. Are you a singular being in a finely tuned universe, or one of countless conscious entities scattered across an infinite multiverse? Does it matter whether your particular pattern of thoughts and experiences is unique, or is the simple fact of your present awareness sufficient unto itself? Take a gentle breath and consider that this very moment of contemplation might be occurring simultaneously across countless parallel universes, with countless versions of you pondering these same mysteries in worlds where the fundamental constants are slightly different, where history unfolded along different paths, where consciousness emerged through subtly different evolutionary pressures. The anthropic landscape doesn't diminish your significance, but rather places you within a context so vast and rich that it transcends our ordinary notions of meaning and purpose. Whether you are alone in a single, miraculously fine-tuned universe, or one of infinite conscious beings in an infinite multiverse, the simple fact that you exist to ask these questions represents something profound about the nature of reality itself. Some cosmological models suggest that our universe might undergo endless cycles of expansion and contraction, each Big Bang followed eventually by a big crunch that sets the stage for the next cosmic beginning. In these scenarios, time itself might be circular, with each universe cycle creating the conditions necessary for the next iteration. But quantum mechanics adds strange new possibilities to this ancient idea of eternal recurrence. If consciousness plays any role at all in collapsing quantum wave functions, then the very act of observation might participate in creating the reality that makes observation possible. Mind and cosmos might be locked in a bootstrap loop, where each creates the other through the mysterious mechanisms of quantum measurement and conscious awareness. This doesn't mean that human thoughts directly control cosmic evolution. Such claims remain unproven and scientifically controversial. Rather, it suggests a more subtle possibility, that consciousness and cosmos might be co-emergent aspects of a single, self-creating process, where the universe develops the capacity to observe itself through the emergence of aware beings like you. Consider how this might relate to your own experience of self-awareness. When you turn your attention inward and observe your own thoughts and feelings, you are participating in a process where consciousness becomes aware of itself. This self-referential loop, where the observer and the observed are aspects of the same system, might reflect something fundamental about the nature of reality itself. The universe might be engaged in a similar process of self-observation on a cosmic scale, developing complexity and consciousness not as accidental byproducts of blind physical processes, but as integral aspects of its own self-discovery. Through conscious beings like you, the cosmos might be literally coming to know itself, creating a feedback loop between awareness and existence that spans billions of years and countless scales of organization. This perspective transforms the relationship between mind and matter from one of separation to one of intimate participation. Rather than being an external observer of cosmic processes, you might be an internal aspect of the universe's ongoing self-exploration, a temporary focusing of cosmic awareness that allows existence to contemplate its own deepest mysteries. Take a moment to rest in this possibility. As you breathe, imagine that each breath is part of the universe breathing, each thought part of the cosmos thinking, each moment of wonder part of existence marveling at itself. While this remains a poetic interpretation rather than established science, it captures something essential about the participatory nature of consciousness in a quantum universe. The eternal return doesn't necessarily mean that every detail of cosmic history repeats exactly. Instead, it might represent a more subtle kind of cyclical process, where the universe continuously explores new possibilities within the constraints of its fundamental laws and constants. Each cosmic cycle might be a variation on eternal themes, exploring different combinations of matter and energy, different emergent properties, different forms of complexity and consciousness. If such cycles exist, then your own existence might not be a unique occurrence in cosmic history, but rather one instance of a pattern that the universe explores again and again across vast scales of space and time. This doesn't diminish your significance, but rather suggests that consciousness might be such a fundamental feature of reality that it emerges repeatedly whenever cosmic conditions allow. We've discovered that matter shouldn't have survived the first moments of cosmic history, yet somehow a tiny asymmetry allowed the universe to escape complete annihilation. We've seen that the vacuum of space seethes with quantum activity. That empty space itself might be the source from which all existence continuously emerges. We've explored the precise fine-tuning of fundamental constants, so exquisite that it seems to require conspiracy on a cosmic scale. We've ventured into the quantum realm, where observation and reality dance together in ways that suggest consciousness might play a more fundamental role in the cosmos than we ever imagined. We've contemplated the possibility that we live in a metastable universe balanced on the edge of transformation. That time itself might be more flexible than we assumed, and that the history of the cosmos might remain fluid until the moment it is observed. Through it all, one truth has remained constant. The simple fact that you exist to contemplate these mysteries is itself the deepest mystery of all. In a universe that, by all accounts, shouldn't exist, you have emerged as a conscious being capable of wonder, curiosity, and understanding. You are not just in the universe, you are the universe becoming aware of itself. As you sit in this moment, whether dawn is breaking outside your window or stars are appearing in your evening sky, remember that every photon of light touching your eyes has travelled vast distances through space and time to participate in this moment of awareness. The atoms in your body were forged in stellar furnaces, scattered through space by dying stars, and somehow assembled into the complex pattern of consciousness that is uniquely you. You are both utterly improbable and absolutely inevitable. A temporary focusing of cosmic possibility into the miracle of present moment awareness. The universe has spent nearly 14 billion years preparing for this exact moment when you would contemplate the impossibility of your own existence. Take a deep breath and let yourself rest in the profound mystery of being conscious in an apparently impossible cosmos. You don't need to solve these puzzles or understand every aspect of quantum mechanics to appreciate the wonder that surrounds you. Simply being aware, simply being curious, simply being present to the mystery is enough. The questions we've explored tonight may never be fully answered, and perhaps that's as it should be. Mystery is not a problem to be solved, but a gift to be received, an invitation to remain open to possibilities beyond our current understanding. In a universe that continues to surprise us at every turn, wonder itself might be our most profound connection to the deeper nature of reality. Whether our cosmos is unique or one of countless parallel universes, whether consciousness is fundamental or emergent, whether we live in a single timeline or countless branching possibilities, the simple fact remains: you are here now, aware and wondering. And in that awareness lies something that no amount of scientific knowledge can fully capture or explain. As our contemplation of impossible existence draws toward its gentle crescendo, we find ourselves standing at the threshold of perhaps the most beautiful mystery of all, the profound interconnectedness that weaves through every level of reality, from the quantum foam of empty space to the vast networks of galaxies that paint patterns across the cosmic dark. This interconnectedness isn't merely poetic metaphor or philosophical speculation. It emerges from the very mathematics of quantum mechanics, which reveals that once particles have interacted, they remain mysteriously correlated across any distance, their fates intertwined in ways that transcend our ordinary understanding of space and time. Consider the photons of light that are streaming into your eyes at this very moment. Some of them began their journey billions of years ago in the nuclear furnaces of distant stars, carrying information about cosmic events that occurred long before Earth existed. Others left the sun just 8 minutes ago, bearing the energy that once resided in hydrogen atoms, forged in the first moments after the Big Bang. Each photon that reaches you has travelled through the expanding fabric of space-time, potentially passing near countless other stars, planets and cosmic structures along the way. Through gravitational lensing, some of these light rays have been bent and focused by massive objects, their paths curved by the geometry of curved space itself. But the interconnection goes deeper than the mere physical journey of light. If quantum mechanics is correct, then every atom in your body has participated in countless quantum interactions throughout cosmic history, becoming entangled with other particles in ways that create an invisible web of correlation spanning the universe. The calcium in your bones might have been forged in the core of a star that went supernova billions of years ago, scattering its enriched material across space, where it eventually became part of the molecular cloud from which our solar system formed. The iron in your blood carries within its atomic structure the quantum signature of nuclear processes that occurred in stellar cores, connecting you directly to the cosmic furnaces that created the elements of life. Take a gentle breath and consider that the oxygen entering your lungs right now has been part of countless other breathing beings throughout Earth's history. It has travelled through the respiratory systems of ancient forests, been exhaled by dinosaurs roaming prehistoric landscapes, and participated in the photosynthetic processes of algae in primordial oceans. This molecular recycling creates a kind of temporal interconnection where your present breath connects you to every living thing that has ever drawn air on this planet. You're not just breathing oxygen, you're participating in a planetary respiratory system that has been operating for billions of years. The interconnectedness revealed by modern physics extends beyond our planet to encompass the entire observable universe. The cosmic microwave background radiation that fills all of space carries within it the imprint of quantum fluctuations that occurred when the universe was less than a second old. These ancient patterns stretched across billions of light years by cosmic expansion, influenced the formation of the first stars and galaxies. In a very real sense, the large-scale structure of the universe, the distribution of matter and energy that makes galaxies and life possible, emerged from quantum uncertainty amplified to cosmic scales. The universe we observe today is a vast, three-dimensional expression of quantum possibilities that crystallized into actuality in the first moments after the Big Bang. As you contemplate this cosmic web of connection, notice how it might shift your sense of isolation or separateness. While this remains a speculative interpretation rather than proven science, the quantum interconnectedness revealed by physics suggests that you are not a separate entity moving through an alien universe, but rather an integral expression of cosmic processes that connect you to everything that has ever existed. Our exploration now brings us to one of the most profound questions that emerges from our journey through impossible existence. In a universe governed by quantum uncertainty and cosmic interconnection, how does meaning arise? How do conscious beings like you create significance and purpose within a reality that seems to be fundamentally probabilistic and participatory? This question strikes at the heart of what it means to be human in a quantum cosmos. Traditional views of meaning often assume a fixed objective reality where purpose can be discovered through careful observation and rational analysis. But quantum mechanics suggests a more fluid picture, where reality itself remains partially undetermined until the moment of observation. If consciousness does play any role in quantum measurement, even in the most subtle and indirect ways, then the very act of seeking meaning might participate in creating it. This doesn't mean that human thoughts directly control reality. Such claims remain unproven and scientifically controversial. Rather, it suggests a more nuanced possibility, that meaning emerges from the intersection between conscious awareness and quantum possibility. Consider how meaning arises in your own experience. When you witness a beautiful sunset, the significance you find in that moment doesn't exist solely in the electromagnetic radiation reaching your eyes, nor does it reside entirely in your neural processing of visual information. Instead, meaning seems to emerge from the interaction between consciousness and phenomenon, subject and object, observer and observed. Some interpretations suggest that this might reflect something fundamental about how meaning operates at all levels of reality. Just as quantum measurements seem to crystallize definite outcomes from indefinite possibilities, the search for meaning might help crystallize significance from the vast space of potential interpretations that surround every experience. This perspective transforms the relationship between consciousness and cosmos from one of discovery to one of co-creation. Rather than simply finding meaning that already exists in an objective universe, conscious beings might participate in the ongoing emergence of significance through the very act of paying attention, asking questions, and seeking understanding. Take a moment to reflect on how this might appear in your own life. When you contemplate the mysteries we've explored tonight, you're not just learning facts about the universe, you're participating in a process where cosmic evolution becomes aware of itself through consciousness like yours. The very fact that matter organized itself in such a way as to ask questions about its own existence represents something profoundly meaningful about the nature of reality. This emergence of meaning doesn't require supernatural intervention or miraculous coincidence. Instead, it might be a natural consequence of the universe's inherent creativity, its capacity to explore new possibilities and develop ever more complex forms of organization and awareness. The quantum nature of reality provides a framework within which this creativity can operate. Quantum uncertainty ensures that the future remains open, that new possibilities can always emerge, that the universe retains the flexibility necessary for genuine novelty and growth. As you sit with these ideas, notice how they might affect your relationship to uncertainty and ambiguity in your own life. Rather than being obstacles to meaning, the open-ended nature of quantum reality might be precisely what makes meaning possible. In a completely determined universe, significance would be as fixed and predetermined as everything else. But in a quantum cosmos, meaning can emerge, evolve, and deepen through the ongoing interaction between consciousness and possibility. This doesn't diminish the reality of meaning or reduce it to mere subjective interpretation. Instead, it suggests that meaning might be as fundamental a feature of reality as mass or electric charge, emerging naturally when consciousness and cosmos interact in the proper ways. While this remains a speculative idea rather than established science, it points toward a universe where the search for significance is not futile, but participatory, not discovering fixed truths, but helping to create evolving understanding. As we venture deeper into the implications of our interconnected yet mysterious universe, we encounter a beautiful paradox that speaks to the deepest questions of existence. How can we feel so alone in a cosmos where everything is quantum mechanically connected? How do we reconcile the vast scales of space and time with the intimate immediacy of conscious experience? This paradox emerges naturally from the strange properties of quantum entanglement and cosmic expansion. While particles can remain correlated across vast distances, maintaining their mysterious quantum connections regardless of the space between them, the expansion of the universe simultaneously carries galaxies away from each other at ever-increasing rates. We live in a cosmos that is both intimately connected and increasingly isolated, where quantum correlations link every particle to its cosmic history, while dark energy drives matter apart on the larger scales. It's as if the universe is simultaneously reaching toward unity and embracing separation, creating both connection and solitude. Consider your own experience of this paradox. As you listen to these words, you're participating in quantum processes that connect you to the fundamental structure of reality itself. The electrons flowing through your neurons, the photons carrying information to your eyes, the atomic processes that maintain your biological functions, all of these are expressions of quantum fields that permeate the entire universe. Yet at the same time, you experience yourself as a distinct individual, separate from other conscious beings, isolated by the boundaries of your skin and the privacy of your thoughts. This sense of separateness isn't an illusion to be overcome, but rather an essential aspect of how consciousness manifests in a quantum universe. The resolution of this paradox might lie in recognizing that connection and separation are not opposites, but complementary aspects of a deeper reality. Just as quantum particles can be both localized and delocalized, both definite and indefinite, conscious beings might be both individual and universal, both separate and connected. Take a gentle breath and consider how this paradox might appear in your relationships with other people. While you can never directly experience another person's consciousness, quantum mechanics reveals that you are connected to them through invisible networks of correlation that span the history of the cosmos. The atoms in your body and theirs were forged in the same stellar furnaces, scattered by the same supernovas and shaped by the same cosmic processes that created the heavy elements necessary for life. You share not just a common evolutionary ancestry, but a common atomic heritage that connects you to every living thing that has ever existed. This shared material foundation doesn't erase the uniqueness of individual consciousness, but it does suggest that separateness and connection are both true simultaneously. You are both utterly unique in your particular pattern of awareness and intimately connected to the cosmic processes that make awareness possible. The paradox extends to our relationship with the universe as a whole. While we may be alone as conscious observers in our local region of space, the vastness of the cosmos suggests that consciousness has likely emerged countless times in countless places throughout cosmic history. Some interpretations of quantum mechanics, particularly those involving parallel universes or multiple worlds, suggest that consciousness might be even more abundant than we can directly observe. If every quantum measurement creates branching realities, then there might be countless versions of conscious beings exploring countless variations of cosmic possibility. As you contemplate this possibility, notice how it might affect your sense of cosmic significance. Rather than being a rare accident in an indifferent universe, consciousness might be a fundamental feature of reality, emerging wherever cosmic conditions allow for sufficient complexity and organization. This doesn't solve the paradox of loneliness and connection, but it reframes it in a more hopeful context. You might be alone in your immediate cosmic neighborhood, while simultaneously being part of a vast community of conscious beings scattered across space and time, each exploring their own unique perspective on the mystery of existence. As our journey through impossible existence approaches its quiet conclusion, we find ourselves contemplating perhaps the most recursive mystery of all, the fact that the universe has developed the capacity to contemplate itself through consciousness like yours, creating a kind of cosmic self-reference that loops back through scales of space and time in ways that challenge our deepest assumptions about the nature of knowledge and identity. This self-referential quality appears at every level of reality. Quantum systems can become entangled with their own measurement apparatus, creating strange loops where the observer becomes part of the observed system. Conscious beings can turn their attention inward to observe their own mental processes, creating recursive hierarchies of awareness, observing awareness. And so we arrive at the end of our gentle exploration through the impossible landscape of existence, having wandered together through mysteries so profound that they transform the very ground beneath our feet. We've discovered that the universe we call home shouldn't exist by any reasonable calculation. Yet here it is, humming with quantum possibilities and conscious observers like you who can contemplate the beautiful absurdity of it all. Perhaps the most extraordinary revelation isn't that the cosmos defies explanation, but that it produced beings capable of being amazed by their own existence. In you, the universe has achieved something remarkable, a temporary arrangement of ancient stardust that can look back across billions of years and marvel at the journey from simple hydrogen to complex consciousness. The next time you find yourself questioning your place in this vast cosmos, remember that you are not an accident, but an inevitability, not separate from the universe, but an expression of its deepest creativity. Your capacity for wonder, your ability to ask these impossible questions, might be exactly what the cosmos has been building toward all along. Rest well tonight, knowing that in a reality that shouldn't exist, your existence is perhaps the most beautiful impossibility of all. your existence is perhaps the most beautiful impossibility of all.